Hey everybody, welcome back. It's April 20th, 420 in 2022. If you're one of those people that likes to celebrate 420, today's your day. We are in Intro to Stats. Today we are going to cover 11.3, which is on doing hypothesis tests for a mean with two sample groups that are dependent. So let's just get that started. And before I did, I just want to start, I want to do another recap. I think these recaps, they help reinforce everything that's going on. So what have we done since the midterm? From the midterm on. So we have looked at confidence intervals and hypothesis tests. And we have looked at, in particular, for our sample groups, we have done a one proportion test, a one means test, and confidence intervals for each of those. And we've done two proportion, and we've done a two mean paired. Today, we're going to cover two mean unpaired. But in our recap, what we want with our sample groups, we want everything to follow a normal distribution. And oftentimes we don't know if it does or not. So we did the tests like proportion, we would do n times p times 1 minus p. We wanted greater than or equal to 10. And we wanted n to be less than 5% of the population. That was for proportion tests. For the mean, we wanted n to be greater than or equal to 30 or approximately linear. And no outliers. So that's where we would go through and do our QQ plot and box plot. Those were our ways of making sure we had what was a normal distribution. We had our nice little bell curve. When it is a normal distribution, we get our normal bell curve, which is what we wanted. And our confidence interval was related to this. The center was the mean or the proportion, whichever one it was. And our confidence interval was either, our confidence interval is outside a certain percentage range. So the percentage is based on the area underneath the curve. So when we want 95% of the area to be right here, it leaves 5% outside. And this would give us a 95% confidence interval. This would be our lower limit, and this would be our upper limit. And we would, in this case, say we are 95% confident. That the true proportion or mean for insert problem info here is between the lower limit, and we give the value, and the upper limit, and we'd give the value. And we'd probably, proportion doesn't have units, but for the mean, you want to give units. Like if it's between 200 minutes and 300 minutes, you want to say the minutes part, because it actually means something. It gives the sentence meaning. And so this resulted in, this gave us, let's call this percentage inside here X%. And when we'd have a two-tailed test, how is this connected to a two-tailed test? For a two-tailed test, like we have here, where there's stuff on both ends, we had X would equal 1 minus alpha times 100%. So for like a 95% confidence interval, this ends up, alpha ends up being 0.05. That would make this X equals 0.95 times 100, which gives us 95%. So there's a connection between the confidence interval and the alpha that we're choosing. When we had a one-tailed test, it's similar. That was when either like HA is less than or greater than. We would only have one side that we're looking at, and that made X equal to 1 minus 2 alpha times 100%. So if alpha equals 0.05, we put this in here, we get 1 minus 0.1 times 100% is 90%. The information we get for the lower limit and upper limit for a 90% confidence interval will match up with the information we have about the hypothesis test at 0.05. Pause and give you a second to write about that. All right, if you need it up longer, let me know and I'll put it back. Otherwise, I'm going to move it. To continue our quick recap, our hypothesis tests. What did we have? We had 5 steps. First step is identify H0 and HA. H0 always has a statement of equality. HA always has something else, either less than, not equal to, or greater than. And it's related to the problem. There's a lot of critical reading and comprehension skills going on here. Not a lot of math, really, if you think about it. At this point, most of the math is being done by the computer. Your task, though, is to do some critical reading and comprehend what the problems are about. Oh, I see a, yeah, sorry, Giselle. Let me put it back up. Got it. Okay, good. So we had H0 and HA. H0 is the statement of equality. It's got an equal sign. HA doesn't. Then our next steps 2 and 3 can kind of be done in any order, but they need to be done before step 4. Step 2, since usually you get this H0 and HA from the problem, we tend to also get alpha from the problem. Alpha, or the level of significance, needs to be identified. That's what alpha is called, the level of significance. And if they don't give one, the default is 0.05. They don't have one. Step 3 is some stat crunch stuff. Do your stat crunch work. Get the test statistic and the p-value. And when you have those two, you compare alpha and p-value. If the p-value is too low, it means it's less than alpha. The p-value is too low, we reject the null, reject H0, support HA. And if the p-value is higher, we do not reject H0, do not support HA. And these ones both have do not in them. I guess if you wanted to write your D's a little cleverly, we could make that look like a D. That's a D right there. So your D from do not is the greater than sign. I just added an extra line and pretended the D was pointing, but the greater than sign, that looks like a 7. There we go. Those go together. And when we have that, our statement is always about HA. At this point, it's always handy to go back and, well, first off, look at what you had up here for it. And also reread the problem, see what the claim was. It's always the claim that's being what we think is going on, or the person thinks is going on. So if we reject H0, if we support HA, there is sufficient evidence to support the claim that, and then rephrase HA here in words. Or if it's text, you can just copy and paste it. It often works too. And if we do not support, there is not enough evidence. And then everything else is the same. Again, the nots go together. I need to look at the contrast in my camera. And that's a quick wrap up of what we've been doing so far. And I think we're ready to dive into, oh wait, that's not quite it. A little bit more. We haven't talked about what we do in StatCrunch and what H0 and HA break down into. Is everyone good with me to remove this page? If you are not, let me know. I'll leave it up for a few more seconds. Okay. So what else can we say right now? Well, let's take a look at what we have for H naught and HA based on our categories. So when we have a one proportion test, H naught is P equals some value. And HA is P does not equal, P is less than, or P is greater than that same value. We did one mean also as well. And this is really the same. The only thing that changes is the symbol that we put there. And again, some specific value. When we did the two proportion tests, H naught was P1 minus P2 equals oftentimes 0, but you can put any value in there. 0 is the common one, just to show one is higher than the other. And our outcomes are, again, not equal to, greater than, or less than, but the same information. Two mean paired is similar. They called it mu D, which is mu1 minus mu2. And that was an equal sign. And over here, it's either not equal, less than, or greater than. And the new one we're doing today is 2 mu, where they're independent. And it keeps the same notation. It doesn't say the, I don't think it says the mu D, but it's mu1 minus mu2. Equals over here, non equals, less than, or greater than. The stat crunch commands that went with it. We always went to stats. Then you have the option to choose proportion stats or T stats. And from that level, you got to choose one sample or two samples. And also paired just for the mean only. They don't do paired for proportion. But paired is mean only. That's an extra option. And for many of them, you had with data or with summary. This applied to all of them. Mu, it did not. The paired one, specifically data only. Everything else was good to go. And that's a recap of our old information. You guys have finished writing that? All right, if you need it longer, let me know. give me a holler. So let's take a look at 11.3. Did I click record? Okay, good. I am recording. 11.3. Where's my mouse? There we go. 11.3, we're doing the two sample with independent means. Or two sample independent, and we're doing means. This is when there's two groups and we're going to compare the mean of each group. With no obvious connection. And even if there's a connection, ideally there's not. You want them to be independent. But two groups means we're going to have two samples. N1 and N2. And N1 doesn't have to equal N2. N1 does not have to equal N2, but it can if it fits the problem. If the surveyors or the people that did the problem made it so. We have our same requirements. It's just now expanded to fit two groups. We still want simple random sampling. That are independent. And we want the population to be normally distributed. And so we either have N1 is greater than or equal to 30 and N2 is greater than or equal to 30, or we can do the QQ plot, box plot for both groups. And often what we want to do it on is that difference. On a column with mu1 minus mu2 stored. Stat crunches allows us to do that pretty easy. And like we do with all of them, we always want N1 and N2 should be less than 5% of their respective populations. That's just a universal one. The big ones, and this is usually the case, this is very rarely broken. Why is that lighting bad? So I am going to stop sharing screen for a second. I want to show you something, what I've done to my office. So I will pin this in my video, pin my, how do I do that? Pin right here. Take off blur. No background. That's my lamp behind there. I got it blocked off with a manila envelope and some thick paper below it to block light from hitting that page. Also, wouldn't have that glare on it. That's some crazy stuff. All right, back to sharing screen. All right, so let's take a look at where we're going in here. In StatCrunch, we're going to go stats, Tstats, to sample. And we're not the paired. The to sample is for the independent one. Here we have the option of data or summary, or again, that power sample size thing. But here it's going to be dependent on the type of problem we have. I'll just look at the summary so we can see what kind of information that we need. So remember when we had a one mean test, we had sample mean, sample standard deviation, sample size for one group. Now we have both. Okay. So what we need for summary. We need a sample mean for N1 and N2. N1 will be mu1, N2 will be mu2. Oh God, I said mu2 out loud. I hear it. I heard it in my head. Stupid Pokemon. What else we got? We got sample standard deviation, which for a sample is S. So we need an S1 and an S2. And we need the sample size, which I already listed up above, the N1 and N2. Notice this option right here, calculation options, pool variances. Let's just tell you about it. Pool variances make the assumption makes the assumption that group 1 and 2 have the same standard deviation and variances. Variances is going to be S1 squared or S2 squared. That's why I said standard deviation and variances. It assumes both. But there is no reason to assume that our groups have this. In most circumstances, there is no reason to assume this. So leave it unchecked. While you're writing that, I'm going to open up a data set. What did I call it? I called it comparing grades. Which should have been on this list already. This is going backwards in time. No, maybe not. There we go. All right, so I'll give you the problem that this data is related to. This should be an open, do edit. It's shared, so if you want to look it up, it's called Comparing Grades Jones-Hefe. So the StatCrunch data set is comparing grades Jones-Hefe. And we have data sets that say spring 19 total and is column 1. And fall 18 total is column 2. And it's got quite a bit of data in there. They're not equal. So I don't want to take the time to write it up on the screen. It'll take too long to write all the data sets or all the data points, but I can tell you what the problem was. This is what was going on. I believed, Professor Jones believed that using the first week of class to cover study skills, time management, growth mindset, faith in oneself or believing in yourself, confidence, I guess, is self-confidence. We spent a week talking about stuff like that other than doing lectures. And I believe that doing that other than doing lectures would increase the average score in the class. So I tested this. Fall 2018 did not have this in effect. Fall 2018, we did lectures. And spring 2019, I did this, no math for the first week. We did, let's just call them life skills. Because time management, believing in yourself, stuff like that translates to more than just class. And these were the results. And I want to test. So what we're going to do is test Jones's claim. at the alpha equals 0.05 level of significance. Now they're not perfect comparisons. I didn't tell you what class it was. These were for this is for intermediate algebra courses, which we do not even teach at COS anymore. But it has a lot of the same content as Math 35, just a little bit lighter. Well, some teachers did it lighter. I kind of taught it at the same level as my Math 35. I expected a lot. I raised my students up. I wanted them to do well. All right. So let's talk about our steps of the hypothesis test. If you need it up longer, just shout. We got our 5 steps. H naught, HA is the first step. And we clearly have 2 groups. They're independent, other than they're taught by the same instructor at the same school. They're students. The students are different students. So they're independent. And yeah, there might be differences between a fall semester and a spring semester, especially for new students fresh out of high school. That first fall is their first college experience. So it's not a perfect comparison. But the only way to test this is to, which I may do at some point, is just do one group where they don't get that stuff and the other group does. So for 2 sample groups, we wanted the average test score. I can't really do individual test scores. This is clearly not a proportions test, because I'm not going to say like the proportion of students that got a, an A or something like that. It was just the average test score goes up. So it's clearly a means test. So we know we're going to have a mu1 minus mu2. And if I think test scores go up, I need to figure out what sign I'm going to put in here. So let's just identify the groups. If I think test scores went up by doing so, and I did so fall 18, F18 was no skills week, and S19 was skills week. Just to break it down. And I think skills week, doing a week of skills, raises test scores. I think that S19 should have a higher average test score or greater than F18 or fall 18 and spring 19, like that, based on the way I worded the question. Alternatively, you could write fall 18. To me, writing it like this seems wonky. Like I said, test scores will go up, but then I show the less than sign. It doesn't mesh in my noggin. But if it does for you and you want to use that way, you can. I'm going to go with this one, which means if I move the F18 to the other side by subtracting it, I get S19 minus fall 18 is greater than 0. So if I label this mu1 and this mu2, I can say mu1 minus mu2 is greater than 0. And that's helped me identify my groups. This will be 1 and fall 18 will be 2. It helped me identify what's going to go where. Okay, so we got our H naught and HA. We want to identify the level of significance, and the problem stated alpha equals 0.05. We had that. I think that's what I said. Yep. And so now we just need to do the claims. And since we have the data, we're just going to use the data. We'll do stats, Tstats, to sample with data. And that's where are the values for sample 1 and where are the values for sample 2. I said fall 8 or spring 19 was group 1. So, conveniently it's in that order. And sample 2 is fall 18. So I'll put that in that one. And make sure, a lot of times when you get the answer wrong, I get students emailing me all the time. Well, not all the time, on occasion. Not enough students email me when they have questions. It's disappointing when people get it wrong and don't ask questions, and then they don't learn, and then they don't do one of the tests. If you've got a question, don't understand something, please ask. A lot, but they'll get I get questions like, I got the p-value wrong. What did I do wrong? And if I don't know what you did, it's kind of hard to answer. But in general, the first thing you should check if it tells you got the wrong p-value is come back here and make sure you got your hypothesis test set up correctly. I want HA to be mu1 minus mu2 is greater than 0. If I don't have greater than 0, I'm going to get the wrong values. This is not in MATLAB though, so whatever value I get works for me. So what did this report to me? This reported that my Tstat is 2.0133984. And my p-value is 0.0237. So that's step 3. Step 4, we're going to make a comparison. P-value versus alpha. My p-value is 0.0237. My alpha is 0.05. My p-value is below alpha. So my p-val is too low. The null must go, or reject the whole. Reject H naught, support HA. And here HA says mu1 minus mu2 is greater than 0. Spring 19 mean is greater than fall 18's mean, but that's not what the test was about. The test was about, do study skills help? So that's what I want to make my claim about, or my statement at the end. And I'm going to support it. So there is sufficient evidence to support the professor's claim. That life skills week, since that's what I called it just now, life skills week is effective in improving the average test score. not average test score, average grade in the class. I didn't measure individual tests. I measured final grade in the class. And you see that sample difference right there? 10.698. That's my mu1 minus mu2. The mu1 minus mu2 average is 10.698. And these were percentage points. The average grade in the spring class went up a full letter grade, which was, so I do it every semester when we're in person. It's kind of hard to do it when it's online because not enough people show up. I do put the content in the Canvas stuff though. That's why there's all that stuff in Canvas. We go over to COS. You may have asked, why is Mr. Jones making me do all this crap at the beginning of the semester? This experiment right here is exactly why. I showed to myself that doing so improved scores. You had learning math with a growth mindset, making time for what's important. That was a time management video. The 168 hours thing was also time management. So we had a bunch of stuff in there. All right, so give you a second to finish writing that down. And then we'll go on to the lecture notes. We got one problem in the lecture notes we're going to do. We'll do one problem from the homework, and then we'll call it a wrap. I was particularly proud of this experiment. I went to a conference for math teachers, community college math teachers, and I gave a poster presentation on it. And a lot of people asked for my email and were asking me questions afterwards. All right, so next problem. This is in our lecture notes that you can find in the file section on Canvas. This is page 134 in 11.3 in our lecture notes. File in Canvas. And it's on paper towels. This is an experiment that took place several years ago. A group of students. It's the paper towels test. So a group of students wanted to test the strength of Bounty paper towels versus Kirkland paper towels. To make the comparison, they wetted each paper towel with the same amount of water and suspended the paper towel between two stacks of books, like so there's space underneath it. They then proceeded to stack pennies on the paper towel until the paper towel tore or broke. The results of the experiment are given in the table below, and the numbers you see are the number of pennies that it took to break the stack. Test the claim that Kirkland paper towels are stronger than Bounty paper towels at the alpha equals 0.01 level of significance. So we have Bounty versus Kirkland. And it tells, the last sentence says alpha equals 0.01. And I am testing the claim. The claim is Kirkland is stronger than Bounty. So like that doesn't really go, the number of pennies doesn't really directly compute unless we think about, well, pennies have got weight to them. And 1 penny doesn't weigh a lot, but 500 pennies weighs a lot. It's kind of heavy. So like if it's a strong paper towel, it can hold up the weight. And if it's not a strong paper towel, the weight will break. I bet they wanted to try this with dry paper towels, and it just took way too much, way too many pennies to make this make it break. So I'm going to assume that the stronger paper towels hold more pennies. And if that's the claim, how can I decide H0 and HA from that? The claim is that Kirkland is stronger than Bounty. Kirkland is stronger than Bounty. And so that means if the penny weight thing is true, that means Kirkland held more pennies or a greater amount of pennies than Bounty, if their claim is true. So if I move that over with subtraction, I have Kirkland minus Bounty is greater than 0. And if I choose Kirkland to be group 1 and Bounty to be group 2, I have a good HA here. So Kirkland will be 1 and Bounty will be 2. That's my HA. The null is obviously where they're equal. And I wrote them in a different order just because I was the way I calculated it. But that's not going to change what I put in StatCrunch. So that's my null and alternate hypothesis. Here's my level of significance up here. I wrote that down already. So now all I got to do is find my Tstat and my p-value. And when we have those, we can make a decision. So hopefully I can copy and paste this. Good. And column 1 was Bounty. And exact Kirkland. I think it's like good to rename these columns. It makes doing the next step easier. And if you're like saving the data and printing it out anywhere or putting it in a paper or, you know, in real life, you want to have your groups labeled. Why is that highlighting? Edit. I didn't click edit. All right. So we're going to go stats, Tstats, to sample with data. And I want Kirkland to be group 1 and Bounty to be group 2. Naming them also helped because Bounty was in variable 1 and it said bar 1 at first. Kirkland said bar 2, and it's kind of confusing to put the bar 1 in category 2 and bar 2 in category 1. So getting rid of the numbers, having names helps. And I had mu1 minus mu2 is of course equals 0 for H0, and I wanted greater than for HA. And I click compute. And I get my Tstat, 8.0217896. And my p-value is less than 0.001. So less than 1 in 10,000. That's the fractional equivalent. So, make a decision time. My p-value is less than 0.0001, and that's less than 0.01 for alpha, which means we are, this is a do not or a reject H naught, support HA. HA was my claim. The claim was Kirkland is stronger than Bounty. So that's what we have evidence to support. There is, I constantly do sufficient, but you don't need to, as long as you put the right words. There is enough evidence. I'll change it this time. There's enough evidence to support the student's claim. This was a project by students. That Kirkland paper towels are stronger than Bounty paper towels. Any questions? We got one more problem. We'll do it from the homework set. I did want to point out one other thing. It wasn't about this one. I meant to do it on the last one. The hypothesis test where we did mine. Notice the p-value is this, and alpha was 0.05. If alpha was 0.01, like the student's paper towel project, then I would have had 0.0237 is greater than alpha. And I would have said, do not support HA. Which means there is not enough evidence to support my claim. But that would be, so that's why choosing alpha is important. That was the idea of that one. Why I brought that up right now. Let's see. I'm going to homework number 18. Or, sorry, homework chapter 11, problem 18. So a researcher wants to determine if carpeted rooms number 11, problem 18. So the researcher wants to determine if carpeted rooms contain more bacteria than uncarpeted. I'm going to make a little note of that. Carpeted is more bacteria would be greater than. Carpeted is greater than uncarpeted. And depending on how they want to force us to write this, If we switch the order around, this could also be uncarpet is less than carpet. I'm not sure where they're going to want me to go on this yet. They always make us pick. The table shows the results for the number of bacteria per cubic foot for both types of rooms. Determine whether carpeted rooms have more bacteria than uncarpeted rooms. So carpet, they want us to go with this one. At the alpha equals 0.01 level of significance. I'll cross off the other one because that's the one we're not using. Normal probability plots indicate that the data are approximately normal, and box plots indicate that there are no outliers. We should have looked at that in the last problem, and we didn't. We'll just make it the assumption that it was working. State the null and alternative hypotheses. Let population 1 be carpeted and population 2 be uncarpeted. So if I move that over to the left, well, H naught is going to be mu1 minus mu2 equals 0. But then if I subtract this over, I get mu1 minus mu2 is greater than 0. So this is kind of how we've had the other ones too. That alpha looks like a 2. There we go. So we have our null and alternate hypothesis. The problem gave us the level of significance to use, so we didn't have to use the default one. Now we just got to find the test statistic and our p-value. So I will open that in StatCrunch. And we will do the test there. Stats, Tstats, 2 sample, and I have data again. My values are in population 1, which is carpeted. And uncarpeted for that one. And we want to come down here. Always make sure you check HA. This is an easy one to overlook. That is the easiest one to overlook. We're going to click compute. And we're going to record our information. Our test stat is 0.077936313, and my p-value is 0.4695. So you've got that all written down. It's time to make a decision. Decision time. P-value and alpha. P-value is 0.4695. Alpha is 0.01. P-value is greater than alpha here. The p-value is too high. So when it's too low, we reject. So when it's not too low, we do not reject. We do not reject H naught, and we do not support HA. HA here was that carpeted rooms had more bacteria than uncarpeted. So that's what we'll make our claim about. Our statement. And I can bring this right back up and use that. Oh, wait, that's not it. We were looking at a homework problem. There is, I'm not supporting it, so there is not enough evidence to support the claim that, and I can literally just write down what they have right here in their question. That carpeted rooms have more bacteria than uncarpeted rooms. At the alpha equals 0.01 level of significance. They like to add that. There's uses to adding it. It lets the reader know, like if this is in a research magazine, a published magazine, that it lets the reader know how strict you are on not wanting to make a type 1 error. How much you did not want to convict the innocent. I did all that on paper. Now I got to just go through and apply this to the math lab answer. So we had mu1 minus mu2 is 0, and mu1 minus mu2 is greater than 0. And that's that one. The way I originally wrote it was mu1 is greater than mu2 up there. For a book that had made by a publisher that includes StatCrunch as part of the program, you think they would write H0 and HA the same way that MathLab does, but do they? No. In fact, they even call it HA here, alternate hypotheses there, and in the homework problem, they call it H1. Just makes you want to, slap them, right? Quit trying to confuse me. I think that's the right answer, though. Like, that's what I got written down. If it's not, maybe I should have checked that first, because if I had that wrong, then everything else is going to be wrong. The p-value, thankfully, I wrote everything down because I didn't know what they were going to ask. Ooh, rounding here. Rounding 0.4695 to 3 decimal places. I'm looking at the 9. The 9's got to round up to a 10. That means this is 0.470 to 3 decimal places. One of those rare events where you round up and the number was a 9. So we came up with do not reject H0. And there is not enough evidence. So I need to find the answer that has that and that. Do not reject H0. There is not significant evidence. This looks like the right one. Let me make sure the rest of the words match. To conclude that carpeted rooms have more bacteria. The other one that says do not reject says there is enough evidence. That's not true. So when we don't reject it, there's not enough evidence. And you can look at the not enough evidence as either way. There's not enough evidence to support the alternate hypothesis, or there's not enough evidence to reject the null hypothesis. So it's just, there's not enough. And that's it. That's it for today's lecture. That's it on chapter 11. We've got 2 weeks of lecture left, and then finals week starts. We're getting near the end. Any questions? And if not, have a wonderful day. Thank you.